Okay, so now we're looking at difference of squares. So remember what that meant again. Difference meant it was a minus of squares. Has to be two perfect squares. Okay, so we're still in your workbook. I'm on page 52, sorry. And I'm going to look at number 27, c squared minus 100. Okay, so what am I looking for here? This is actually the only way you can factor two terms besides just taking out a GCF. There's no way to do it otherwise. It has to be a minus sign in the middle, difference, and it has to be the difference of something with an even exponent or a perfect square here and a perfect square here. So this is a difference of squares. So what do? Make two sets of parentheses. Take the square root of the first, put it in each of the first spots. So in this one, that means I'm making two sets of parentheses. Take the square root of the first and put it in each of the first spots. Take the square root of the last. Put it in the last spots. So 100 has a square root of 10, so I'm going to put 10 here. I'm going to put 10 here. And then 1 plus, 1 minus, 1 plus, 1 minus. And that's the answer. Because keep in mind what we did the other day when we had the problem that looked like this. The outsides and the insides were the same product, but different signs. So they cancel each other out. That's why there's no middle term. Okay? So I'm going to go to number 29, 4a squared minus 25. Two terms. It's the difference of two perfect squares. So I'm making two parentheses. 4a squared is 2a times itself. 25 is 5 times itself. Since it's no middle term, 1 plus, 1 minus. Of course, you could have the minus first and the plus second. It doesn't matter. But that's your answer. It's very easy. I'm going to go to number 31, 25x squared minus 144. Difference of two perfect squares. Two separate parentheses. Square root of 25x squared is 5x. Square root of 144 is 12. 1 plus, 1 minus. How about one more? One more that looks difficult. Actually, I'm going to go to number 35, 24e squared minus 54. Wait, did I say 25? 35. Now, at first thought, it looks like you can't factor this because 24 and 54 are not perfect squares. But what goes into both 24 and 54? Well, 6 does. Anything bigger? 12, nope. 6 does. So I'm going to take a GCF out because this we should always look for first, if there is one. So this is why I was confused on some of your homework, because some of you took GCFs out of things, and we hadn't done that. This is the first thing I'm saying in these contexts, these problems till now, so that's why it was a little weird to me that you did that. But Anyway, if I take the GCF out of 6, well, what's left? 6 times 4 is 24. 6 times 9 is 54. Now, if I leave that 6 aside, I still need it because I'm factoring. I'm not like totally removing things. I'm breaking it down into smaller pieces. But the 6 is already out there. But look what's inside. Difference of perfect squares. So I can now say 4e squared is made up of 2e and 2e. 9 is made up of 3 and 3. 1 plus, 1 minus. And the more steps with the GCFs like we have, we're gonna be using that outline a little bit more. You know, and I now see that I want to look at number 43, last one. This is a PST, maybe. 100z squared minus 120z plus 36. So let's see. They do have a common factor. 2, no, 4. 4 would be good. Can we take anything bigger than 4? 9, 6, no. If we take out a 4, we're left with 25z squared minus 30z plus 9. So I already took that 4 out. It's got to be in there. If that's a PST, then I should be able to do that. And the square root of 25z squared is 5z. The square root of 9 is 3. Take the middle term sign. 15z doubled is 30z. So this would be the fully factored form of number 41. Okay, that's it.